Hello, students. So this is an example of a video you can make for your intermolecular forces or IMF assessment. So in the video, I'm going to be talking about what intermolecular forces are, what types there are, and the most important type or most important type for us. Okay, so there are what are intermolecular forces first of all. So intermolecular forces are or I'm going to say IMS from now on to make it easier. IMS are the forces between molecules. Okay? There are four different categories, four different types. So the weakest are London dispersion forces, and these occur between nonpolar molecules. So two nonpolar molecules will have London dispersion forces, and these are the weakest. The next strongest are dipole induced forces. Okay, so these forces occur between a polar and a nonpolar molecule. And what happens is that the polar molecule pulls those electrons towards itself, causing a difference in electronegativity in the nonpolar molecule. Okay, the third type are dipole dipole. So dipole dipole are stronger interactions that we see generally between polar molecules. And we got to remember that polar means an unequal sharing of electrons. The more electronegative atom will steal the electrons from the less electronegative atom. And how do we determine electronegativity? Well, we start from fluorine. So fluorine is the most electronegative atom. And atoms that are elements that are around fluorine on the periodic table, we deem those electronegative. So nitrogen, oxygen, and those types of atoms will steal those electrons from uh, less electronegative atoms like sodium or hydrogen. All right, and the strongest type of intermolecular forces are hydrogen bonding, and we generally see hydrogen bonding between molecules with oxygen, nitrogen, and fluorine. Okay, and a hydrogen bound to it. And what's going to happen is that those oxygen and nitrogen and fluorines are going to pull electrons away from hydrogen towards itself, producing a very strong dipole. So that those oxygen, nitrogen, fluorine atoms are very electronegative. They pull electrons towards it, becoming more negative, causing the hydrogen that's attached to it to become more positive. And that's going to keep reacting. It's going to keep not reacting, but you're going to see the same type of attraction present throughout that whole substance. Okay. Now, why do we talk about IMFs? Why do we talk about hydrogen bonding? Well, it helps describe our interactions. Remember the video of the gecko climbing up the wall? Okay, there's a reason that gecko can climb up the wall. It has special little pads on its I guess its feet that allow it to stick to the wall in a certain way and not to fall off. Well, I can't do that because I don't have that same type of interactions between my skin and the wall. Okay, so it also can explain. It also can explain why we sweat. Okay, so we sweat as a response to cool down when we overheat. Now, why do we use water for sweat? Why do we even use water for any of our biological processes? Well, one of them is due to water's high specific heat capacity. So, what is specific heat capacity? And I know I'm throwing a lot of definitions at you. Yours doesn't have to have as many, yours can be more compact. Again, I'm only looking for 1 minute. Okay, only 1 minute. So let me finish talking about specific heat capacity. It's basically just saying that water has to absorb more heat before its temperature can change. Okay, so its temperature changes slower than other substances. So, a metal pan will always heat up faster than a pot filled with water. Okay, that metal is going to heat up faster because it has a lower specific heat. So we use water. Our body uses water and sweats, this water absorbs the heat or energy from our skin. The water evaporates, and that energy from our skin, using my hand as an example, that energy from our skin gets transferred to the water and it gets transferred to the surrounding atmosphere. And eventually our body cools down. So that's an example of what we call evaporative cooling. Okay, so now this video is over 5 minutes long. Yours only has to be a minute. So what you can do is just quickly sum up the different types of intermolecular forces. And then I really want you to hit on hydrogen bonding. Okay, so give me an example of hydrogen bonding we talked about during class. If you're going to record a video, remember you have three options for your assessment. You can write a little essay and maybe 2 paragraphs. Okay, and you can do your essay, maybe a couple paragraphs. You can do your the one page with like diagrams and a flow chart that show the different types of IMFs. And finally, you can do a video. Don't make the video too long. Obviously, not as long as this one. Maybe a minute, maybe 2 if you want to stretch it and give some examples. That would be great. Okay, so consider those 3 for our assessment. Okay, that's taking place of a quiz or a test. So really consider that. And remember, that's going to be due, if you're in period 1 or 3, that's going to be due tomorrow night by 6. And if you're in period 4, 5, and 6, that's going to be due Friday night by 6. All right. Remember, come to office hours if you have any questions. I'll see you next time.